Hello everyone, today we are going to solve the weakest rows in a matrix problem. It is a Leetcode easy level problem. So let's understand the problem first. So we are given in a matrix. We are given a matrix which consists of ones and zero, where ones represent the soldiers and the zero represent civilians. The soldiers are positioned in front of civilians, and the ones are appears to be the left of the each row. Okay, and the row 1 is weaker than row j if the number of rows in I is less than the number of rows in j, and the if the number of soldiers is same, then I if I is less than j. Okay, so what do you have to do? We have to return the indices of the k weakest rows in a matrix from weakest to strongest. Okay, so we have an input we have this input, and we have to return three weakest row. So from weakest to strongest. So let's find the number of soldier in this. It have two. This have four. This have one, two, and this have five. Okay. So this is the number of soldier. So which is the weakest row? Weakest row is this, because it has less number of soldiers. So first of all, let's put this in one vector: 2 4 1 2 5, and let's sort it according to number of soldiers. So it will be 1 2 2 and 5. Okay, now we need to return first first k, and k is 3. So we are going to return 1 is here. So 1 is at which position? 0 1 2 3 4. So 1 is at 0 position, so we have to return 2. 1 is at second position, and other second is at 0 position, then 3. Okay, so we have to return this. Why it is 203, not 230? Because I if I is less than j, then it will be the weakest. Okay, so let's try to understand how we are going to solve this problem. So what we are going to do here is, first of all, we will take one vector. We will vector in this vector we will take a pair of vector. Let's say soldier count. It will store the count of soldier in each row and the row number. Okay, count and row number. Okay, so let's create this vector first. So here it is 2 comma row number 0. It is 4 comma row number 1, 1 comma 2. It is 2 comma 3, and 5 comma 4. Okay, so this is our vector soldier count. This is our vector. Now we are going to sort this vector according to the count. So how it will be? It will be 1 1 comma 2, then 2 comma 0. If 2 is same, if first element is same, then we sort according to the second element. Okay, which is a pretty default way of sorting in STL. Okay, so then 2 3, and then we will have 4 1, and then 5 4. Okay, so from this we are going to return our first k number, that is 1 2 3. We have to return this, but we have to return only and only the row number. That means we have to return only this. So we are creating one more vector, which is, let's say, answer, and we are going to post first k element. This is soldier count I dot second, and we will loop it k times. Okay, and return that answer. That will be our answer. I hope this makes sense. So let's see the code to understand it more. Okay, code of the Manson solution. So what we are going to do, we first find the row number, then the column number, then we are creating a soldier count one vector of pair, then we are iterating over the matrices and count the number of ones in it, and then we are storing it in another vector soldier count and with count and I as a pair. Okay, then we are sorting soldier count, and it's sorting, first it will sort according to the first element which is count, and then according to the second element if count is same. Okay, then we are taking one more variable which is our answer. So we are pushing our second which is row number k times. So we are storing k number here and then returning that answer. So what is the time complexity of this solution will be um m into n, where m is the row number and n is the column number. And what is the space complexity? So space complexity will be of m. Yeah, space complexity will be of n. So can we improvise this solution? If you see, yes, we can improvise this solution. So let's see how we can improvise the time complexity of this question. Okay. Okay, so let's see the second solution of this question will be, so what we are going to do, rather than iterating all over this row, what we can use is binary search. And the reason why we can use the binary search is because the row is already sorted in the descending order. So what we can do, we will find the last occurrence of one. We are going to find the last occurrence of the one. So let's see what is the last occurrence here. Last occurrence is at 1th index. Last occurrence here is at third. Last occurrence here 0, 1 and the here 4. And we will increase 1 to get the count of number of ones here. So here number of ones will be 2, here 4, here 1, here 2 and here 5. So there will be the number of ones we can use by finding the last occurrence of 1. Last occurrence of 1 plus adding 1 into it, and we will get the count of 1. Okay, so we will use this, and because of that our time complexity will be reduced to O of m into log of n, and space complexity will be O of m, and rest of the algorithm will be same. So let's see the code where we are first declaring our soldier count, and then it is storing the pair of count and I, and it's sorted in the similar way the solution one. Just the difference will be that we are calculating the count. First we are iterating, we will taking the O of n and making the all over complexity of O of m into n, but right now it's taking log of n, which is using the binary search. We are finding the last occurrence, and finding of last occurrence is very simple. We are taking start equals to 0 and end equals to mat into size, where mat is basically a row. Okay, so we are passing each row, and then if that element is 1, that means we have found the 1, but we have to find the last occurrence. So for the last occurrence we have to move our start pointer to mid plus 1, so that we can find the last occurrence. And if our and equals to, it will be 0. If it is equals to 0, then we are going to do and is equals to mid minus 1. Okay, then we are going to return our answer. Okay, answer will be the index of the last occurrence of that one in that row, and then we are storing our count, and the rest procedure is same as the solution one. So the time complexity is reduced from O m into n to m into log of n, and space complexity will be similar to O of n of m. So yeah, this is a pretty much true solution of this problem. If you have any doubt in any of the solution, then you can ping me in the comment section, or if you want to check the source code, then you can check the description. Thanks for watching.